All right, I think we'll get started. It's 10:15 for me and different times across the world here. So why don't we start just to keep time going? I hope everyone can hear me, but I want to welcome you to the session, the last full session of the conference. This session is Semantic Approaches in Design Studies. I'm John Cagan from Carnegie Mellon University in Pittsburgh in the US, and welcome. We have 4 papers that I think are all quite interesting, all focused on the issue of how we look at understanding how to mine and look at communication during the design process. When you group papers together, you have to sort of look at the high level, what are these all about? I think that's really the focus, and it's a very current area, one that is important that we start to focus more and more on as we really try to mine conversations and help direct the design process. So we have 4 papers. Evan will be our moderator and helper, and he's going to run these for us, and then afterwards we'll have a discussion. I really encourage participants to use chat to get their questions put in. I really hope we'll have some great conversation, both for individual papers and the panel as a whole. And our first speaker today will be Georgi Georgiev, who's an associate professor in design research and digital fabrication at the University of Oulu in Finland. And he works broadly in the area of design creativity. So we have a very interesting paper, and I'll also point out that he's managing editor of the International Journal of Design, Creativity, and Innovation. And Ivan, if you could please have our first paper, which is entitled Semantic Analysis of Engineering Design Conversations.
Hello, I'm Georgi Georgiev with the University of Oulu, Finland. On behalf of my co-author, Danko Georgiev, from the Institute for Advanced Study, Varna, Bulgaria, I would like to present our work on semantic analysis of engineering design conversations. In this study, we represent the design problem solving as a dynamic semantic network that evolves in time. This happens from the initial idea to the finally developed solution, like in this example. To examine the dynamics of this network, we quantify 4 semantic parameters that are closely related to design. These are abstraction, which quantifies how generalized is a word, polysemy, which quantifies the number of the meanings of a word, information content that quantifies the amount of information conveyed by a word in a particular context, and semantic similarity that quantifies how alike are 2 words. The aim of this study is to explore the applicability of the outlined semantic analysis approach for dynamic evaluation of engineering design processes. To its aim, we conducted a case study using data from 10th Design Thinking Research Symposium dataset, which contains transcripts of design review conversations. These are collected not in experimental conditions, but in real-world educational settings. For our case study, we use one team from the mechanical engineering dataset that was successful in their solution. This team develops a portable electric tow bar. The device could pull a light aircraft at short distances across the ground. We examined the 3 design review conversations of this team and quantified the dynamics of in 3 data points. The results from the first conversation, concept design review, show that abstraction and semantic similarity do not change considerably over time. However, polysemy and information content initially increase and consequently decrease over time in the conversation. The following final design review conversation conducted in informal settings to the project manager and project engineer exhibits different pattern where the abstraction and semantic similarity rise and then decrease in time, and polysemy is decreasing while information content is increasing. These patterns of the conversation exhibit similar patterns to conversations conducted in the context of industrial design and pertaining per successful solutions. Further, the third conversation is part of the competition presentation, where the team gives a presentation to external jury. Here, polysemy and information content exhibit similar patterns to the first conversation, initially increasing and then decreasing in time, while abstraction and semantic similarity exhibit more changes compared to the first conversation. Abstraction is initially increasing and consequently decreasing, semantic similarities decreasing and then increasing. Our method allows quantification of processes in design problem solving, and overall it provides a tool for objective evaluation of engineering design problem solving conversations in educational settings. Can be utilized for detailed examination of different solutions or particular conversations pertaining to such solutions with particular importance for the education. We believe the method has potential for analysis and support of engineering design problem solving process.
Great, thank you. Thank you very much. So we're going to look at all four presentations first, and then we'll have questions first for the different individual papers and then for the panel as a whole. So our next paper is by Jihan, who is an assistant professor at the School of Engineering at the University of Liverpool. His research is focused on design creativity and computational creativity. And the name of this paper is Computational Conceptual Distances in Combinatorial Creativity. Evan?
Good afternoon, everyone. This is Jihan from the University of Liverpool. And today, I'm going to talk about computational conceptual distances in combinational creativity. Combinational creativity involves unfamiliar combinations of familiar ideas. And here, ideas can be concepts, words, images, sounds, and etc. It is one of the easiest forms of creativity for humans, because it is a natural feature of human associative memory. Examples can include Lego bricks and Apple Watch. Conceptual distance is a measurement of the distance between two concepts or two sets of concepts. And it is highly associated with design creativity, especially idea generation. And previously, we have explored conceptual distance in combinational creativity from design experts' perception. So what we did is we collected 200 combinational designs from the winners of design competitions, such as Red Dot. And then we identified the two ideas that formed the combination, and we called it the base and the additive idea. And then we gave the table to several design experts and asked them to identify whether the two ideas, the base and additive, are closely related or far related. So the result tells us that far related ideas are employed more often. Also, far related ideas could lead to designs that are more creative than closely related ones. And then we want to understand, what do computers think about the conceptual distance? So we have employed the same combinational creative design sample set to provide like a benchmark. And we have used two computational tools for measurement. The first one is ConceptNet, and the second one is WS4J. And because WS4J involves several algorithms So we have selected WP and LCH. And here we propose that the distance values which are lower than the mean value indicate far-related distance, and the ones higher or equal to the mean value indicates closely related distance. And here shows the results. And we can see here ConceptNet produced a similar result as the expert designer. So more designs are from far-related ideas and fewer from the closely related ideas. However, WP and LCH produced a slightly different result. And what we are more interested in is actually the creativity scores versus their conceptual distances of combinational creative designs. So we selected 10 designs, and we asked several designers to evaluate their creativity scores by using creative product semantic scale. And then we pair them with their conceptual distance and put it in this table. So from this table, again, it says that expert designers and ConceptNet, they produce a similar result. So when expert designers indicate a design is closely related, and ConceptNet tends to indicate the same. Okay, and WP and LCH has a slightly different result as well. So, and then we calculated the mean creativity scores of far-related and closely related combinational designs. And the result indicates that for all 4 of the measurements, far-related designs are more creative than closely related designs with moderate to large effect sizes. So, in conclusion, different computational measurements have yielded different results because of the algorithms used. And also, the ConceptNet measurements tend to produce a more similar outcome to the expert designers. And for the study concerned, all the measurements, the 3 computational measurements as well as the expert designers measurements, have shown that far-related ideas could lead to combinational designs that are more creative comparing with closely related ideas. And also, we have planned further studies that involves more design samples and more computational conceptual distance measurement tools. Thank you. That's all.
Thank you very much, G. So we again, we'll go through all of our presentation first. Starting to see some questions in chat. Please encourage you to put them in chat, and we'll also open this up afterwards. Our third paper, I don't see our presenter with us, but we'll present the paper. Yeah?
I think he is present, just not sharing his screen currently.
Oh, okay, great. If you could, we need to have you join the panel, please. That would be great. I will still introduce the paper. Nasreddine Dehaibi. Nasser is a engineering at Stanford. His work focuses on helping designers learn about customer perceptions and products using machine learning tools. And presently, previously Nasser studied at the University of Michigan. So the title of this paper is Investigating Interrelated Reliability of Qualitative Text Annotations in Machine Learning Databases.
Hi everyone, my name is Nasreddine Dehaibi, and today I'll present our paper on investigating interrater reliability of qualitative text annotations in machine learning datasets. The advancements in machine learning enable designers to learn about customer needs in new ways, but they also present their own challenges compared to traditional approaches. One challenge in particular occurs in supervised learning, where we have manually annotated data, such as the example shown here, where we have annotations of reviews based on certain criteria. In computer science, a common way to assess the quality of these annotations are using metrics like precision, recall, and F1, which provide an external validation. In design research, however, we rely more on internal validation metrics such as inter-rater reliability. There are different ways to measure inter-rater reliability based on the type of data that you have. In our case, we're interested in qualitative text annotations, and so we focus on Krippendorff 2 alpha in this presentation. This leads us to our research question, which is Krippendorff's U-alpha applicable as a reliability measure of text annotations for machine learning datasets? I'll give you a brief explanation of how Krippendorff's U-alpha is calculated. Here we have an example of a review with two annotations, and we want to compare how similar they are. For each annotation, we break them up into different sections, and we quantify each section based on where it begins and how long the section is. And we want to repeat this for each section in the annotation, as well as for each annotator. We also want to keep in mind how many annotators there are in total, as well as the total length of the review. Using the quantified sections, we can then calculate the observed disagreement and the expected disagreement in order to determine Krippendorff's U-alpha. The idea here is that the higher the Krippendorff's U-alpha score, the closer the annotations are together, and therefore we can assume that the annotations are more reliable. To answer our research question, we acquired a machine learning dataset with qualitative text annotations, and then we calculated the reliability on that dataset using 4 implementations of Krippendorff's U-alpha. These implementations differ based on how we determine the difference between the annotators, whether it's using letter counts or word counts, or first pre-processing the annotations with natural language processing, for example, removing stop words. The ideas behind these different implementations is to be able to tune how sensitive the reliability measure is based on what we may desire. The dataset that we used here was generated from a prior research project that we worked on, where 1,474 product reviews for French presses were annotated by 900 participants from Amazon Mechanical Turk based on the 3 sustainability criteria: social, environmental, and economic. The external validation metrics shown below suggest that the annotations were reliable, and we want to compare that now with internal validation metrics. The top left figure shows the aggregated results for the 4 implementations of Krippendorff's U-alpha and the 3 sustainability criteria. And we can see that they range between -0.1 to 0.1, which suggests that there's little reliability in annotations and is contrary to the external validation metrics. The other 3 figures disaggregate these numbers for each of the sustainability criteria, and we can see that they all follow the same pattern, where the most common category of Krippendorff's U-alpha is less than 0, and the second most common category is between 0.66 and 1. We dug into this deeper by inspecting the reviews that had the lowest Krippendorff's U-alpha scores. And what we found is that the annotations were in different places, but semantically they were referring to the same information. And so we proposed that in the context of machine learning, it might be preferable to have low agreement in order to collect multiple perspectives and gain more information. One way that Krippendorff's U-alpha may still be useful is by clustering. In this case, we had annotators working with sustainability criteria. So one perspective that may have been prevalent across all annotators is that products that are sustainable are easy to use. However, other perspectives may depend on the demographics. So perhaps older customers will focus more on products that are easy to use with family, whereas younger customers may focus more on convenience. And so when it comes down to annotator reliability, we suggest that precision, recall, and F1 are still the better measures in the context of machine learning. To conclude, we discussed how a low Krippendorff's U-alpha may not reflect annotator agreement or performance, but can still be useful for clustering, and that recall, precision, and F1 are still better reliability indicators. I'd like to end by mentioning that the results and discussion of this study are limited to the context of highly qualitative annotation tasks or machine learning datasets. Thank you for listening. I'm happy to answer any questions.
You and glad we have you on the panel now. That's great. We have one more presentation, and then we'll open this up for discussion and questions. The last presenter is Niccolo Becattini, who's currently an assistant professor at Politecnico di Milano. His research focuses on the design methods and tools, with a particular focus on design cognition, design creativity, and innovation. And his paper is entitled Exploring the Applicability of Semantic Metrics for the Analysis of Design Protocol Data in Collaborative Design Sessions. Everyone?
Hello, everybody. I'm glad to attend this presentation entitled Exploring the Applicability of Semantic Metrics for the Analysis of Design Protocol Data in Collaborative Design Sessions. I am Niccolo Becattini, Assistant Professor at Politecnico di Milano, Italy. My co-authors are Gaetano Cascini, Politecnico di Milano, and Yazan, Barhoush, and Georgi, Georgiev from Ubicomp, University of Ulu. As the title of the presentation suggests, we aimed at checking the potential of natural language processing techniques on existing transcripts of collaborative design sessions. We used 3 transcripts from 3 different co-design sessions from a controlled experiment carried out within the Spark project. These were processed considering the nouns after the removal of stop words. The lexical database for the analysis is WordNet. The computational pipeline returned the scores for each of the segments, more than 1,000 per transcript, according to 4 metrics. These scores get processed to check what kind of information could be potentially extracted from semantically analyzed protocols. The protocols share the same design task as an input, the design of the external packaging for a pumpkin soup bowl to be sold in supermarkets. The co-design sessions involved 4 different people each, 2 designers and 2 potential consumers. All the subjects carried out the experiment once to avoid any priming effect. Each co-design session was carried out in different conditions. One co-design session was carried out with just traditional tools, marker, pen and paper, and no technological support. In the second one, co-designers visualized the prototype of the packaging on a real product with augmented reality via a tablet. In the third condition, co-designers visualized the design with spatial augmented reality, a white painted prototype with its real external aspect rendered through projectors. Each of the 4 metrics has its computational pipeline depending on the relative and/or absolute position of the noun in the WordNet thesaurus. Abstraction measures how a node is generalized compared to its most specific instance. Polysemy measures how many meaning a noun takes. Information content measures the amount of information carried out by a noun. And then similarity, that measures how alike 2 nouns are. The semantic analysis of the 3 protocols therefore produces 4 scores, 1 for each of the selected metrics. The analysis proceeds segment by segment. Therefore, each segment gets 1 score for abstraction, 1 for similarity, 1 for information content, and then 1 for polysemy. These scores per segment allow the identification of descriptive statistic for the 4 metrics for each of the protocol. Therefore, we run 3 comparisons with a progressive degree of detail. The first one regards the protocol as a whole, considering it as a black box. The time dimension here is missing. The distribution of scores for the 4 metrics provided us with descriptive statistics. That is the statistical moment up to the 4th order shown in the bottom left corner. Each of these moments have been compared to the same moment measured for another protocol in order to verify the magnitude of inter-protocol differences. The second comparison considers the evolution of the design processing time. Each protocol is divided by segments into quintiles. For each quintile, we measured the average value for the 4 metrics. Here, we compared how much the trend for a protocol is correlated with the other 2 protocols in time by metrics. Then, the third comparison considers the succession of segments one by one within a single protocol. Here, we combine the score for multiple metrics with the purpose of identifying critical moments in the protocol. Scores above or below a certain threshold value lead to peak and valleys. The assumption here is that coherence of peaks and valleys across the 4 metrics lead to a critical moment or episode. These episodes have been spotted and compared to the critical moments previously identified in protocol with standard protocol analysis. The results show that we cannot distinguish any main difference if we compare the protocols against each other, neglecting the time dimension. All the protocols had the same purpose and design task to deal with. Therefore, we can expect that they also have an overall similarity. The difference, in fact, here is smaller than 5%. If we start looking at the design process evolution, thus considering time, we see that the analysis with quintiles highlight a strong similarity between the sessions carried out with the technology and the very well-marked dissimilarity between these 2 and the co-design session not supported by any ICT tool. At last, within the same protocol, we observe that there is a good correlation between the segments marked in the protocol with standard analysis and the critical moments identified with the combination of scores from the 4 metrics. The correlation is yet to be perfect, but results are promising. Previous studies have already checked the applicability of the metrics from a computational perspective, but this work showed that the semantic metrics are also applicable to distinguish two or more protocols from each other as soon as we shift from a comprehensive viewpoint on the protocol and we move to its evolution in time, despite not all the metrics appear to be equally effective in showing these differences. The fact that the application showed a relatively good correlation with the identification of critical moments in the protocol suggests that the approach could be used to assign markers to the protocol before the standard protocol analysis, suggesting the investigator where to look at with higher priority. The computational power required for the analysis showed that this work could be potentially carried out in real time as soon as the technology evolves. Eventually, the adoption of a general-purpose lexical database for the design domain considered in the protocol could have led to less precise outcomes. We expect that a similar investigation with a tailored lexical database, independently from the design domain, can provide more precise answers and satisfactory results. It's all from my side. Thanks for your attention. I'm glad to receive your questions.
Great, thanks very, very much. So we're going to now turn to questions in general and also for the panel. What I'd like to do is start with each paper individually, and then after that we can open this up to look at the themes across the papers. Sebastian, I see you actually have a well. The first paper, just to remind you, was Georgie's Semantic Analysis of Engineering Design Conversations, and Sebastian's Rexy. I see you have a question. I don't know if you want me to ask it or if you would like to. I'll give you a second to join in. Otherwise, I'll just ask it. Okay, go ahead. So the question was, did you also look into the different conversation behaviors of different roles within design teams? Were there different roles in your teams?
Thank you. This is a very relevant question, actually. No, in this data, we did not look into the differences between the different roles of different participants. However, in our consequent study, which is actually was just recently accepted as a journal paper, and should be online in the next week, I think, in the Journal of Design, Creativity and Innovation. We use data from industrial design, not from engineering design, like here, and we looked into the two main roles in such conversations, those of students and those of people who instruct, either teachers or external experts. And in terms of creativity, they have very distinct roles, and they are highlighted by the semantic analysis. Very shortly describing this, instructors have higher priority on creativity aspects such as usability, and students have much less focused priority on aspects such as value. But together, the role of both parties together is distinctly focused on overall creativity and on originality.
Great, thank you. Okay, great. So are there any other questions from the audience? I have a couple, but I was wondering if anybody has something they'd like to ask at this time. One of my questions is sort of on the issue of resolution and time. You have these four metrics that you're using. How sensitive are they in general? And to relationships within each other and variation, I guess, what's the distribution of them, and does that change over time, or how do you map that over time?
Actually, our earlier studies only used the least precise division in 3 time points. like this one in the engineering design conversations here. But slightly later, the study with Niccolo, we went to a little bit more precise division. This is quintiles, and it shows better results there in that sense. Like increasing the fidelity of the analysis in terms of time chunks is better. Certainly, there is limitation from the opposite side. If it's too small time periods, it would exhibit too many too frequent changes in the parameters, let's say.
Okay, great. Let's see. And I guess I have the same question probably for Niccolo, although you guys are collaborators, so I'll probably get the same answer. But at least in terms of your work, you have these 4 different areas: polysemy, abstraction, information content, and similarity. And what kind of alignment, or is there an alignment that you would expect with the work that you were out, or what were you expecting in terms of alignment between them in your particular study? As one increases, another one decreases, is there any kind of relationship between them you might anticipate?
I was talking to myself as my mic was muted. Sorry for this. Can you hear me?
No, actually, no. This is actually for. This one's for Georgi, and then I'm going to ask you when we get to your paper relative to your paper. So that's fine. But I was just curious with the study that you ran, what alignment did you anticipate, and would you expect between these?
There are certain limitations. For example, from a couple of studies we have conducted with this method, we see fairly good alignment in terms of distinction of successful and unsuccessful ideas or solutions. From the study with Niccolo, we can see possibility for distinction between different technologies used in the design. So in these 2 aspects, the alignment is probably there are good perspectives for alignment, but certainly the method is having limitations. For example, as Niccolo mentioned, more specialized tool than WordNet might be produce better results, for example, in that sense.
Okay, great. Thank you. Okay, why don't we move on to the next paper, because it's actually perfect timing because we have a question. And this is G's paper on computational conceptual distances and creativity. Oscar, would you like to ask your question? You can come on to ask it, or I'm happy to do so for you. Give you a minute. The question is, can you explain how you determined the base and additive components from the red dot designs?
Okay, so for us, what we did is we asked, I think, a few design experts to do this. So what they do is they go through all the components and identify all those designs and identify which is the base. The base is basically the base of the idea. For example, there's something like a cup of something, or it is a cup but with some additional things. But the base of this product is a cup, so that is the base. And for additive, it's something that is add on to the base idea. However, in some situations, it's quite to tell which is the base and which in sometimes as well. But we use an expert to identify that for us. So we provided what we mean, about base and additives. Okay.
Great, Oscar. Do you have any follow-up? Otherwise, I'm going to. Looks like you said okay. Thanks. That's great. I'm going to ask a couple of questions, though. If anyone others has some for G, please add them to chat. So, I've looked at issues. I'm familiar with the near versus far and find it fascinating. I guess a couple of questions for you. Is close versus far relative or absolute?
For me, I think it's hard to say. I think it's relative, especially for computational measurements. For human, I think maybe it's absolute, but it also depends on who is evaluating it. But for computer, I think it's relative. So there are like different algorithms and different methods. Some measure the similarity between two nouns or two concepts. Some measure the relatedness between two concepts. So I think all of them are actually like relatedness. So it's like one thing we found in our research is difficult to say is how do we define what is far or what is near or what is close in computational measurements. So what we did is we calculated the mean value of the measurements, and then we said the value is larger than the mean, then we think it's far, or it is smaller than the mean, we think it's close. But we think it's maybe not that accurate. So we're still trying to find a best way to define what is far, what is close. Yeah.
So I would expect that, or I guess I'll ask it as a question. This would really be relevant to the population you have and the breadth of that population, and depending on what's included or not, that could change. What's near as far, what's far
so
could be
that's
near.
what is done in our study. But I hope it should be absolute. So if it is absolute, I think it will contribute to other work. If it is absolute, it can be used in basically like other computational tools. So it does not need to be depend on the population we got, or it can be used on any products. But I don't know. At the moment, we are not really sure how to define what is close and far at the moment. Yeah.
Okay. So, what you also stated that, from what I can tell, that creativity and far are related. What about usefulness? Did you look at usefulness at all? Because they're not always aligned,
it's always
right?
aligned. I think we did look at the usefulness. So usefulness basically, it's not that. I think it's not really that related to the conceptual distance. Sometimes people might think close is more, like if two ideas are closer, they might be more useful. But it's not that, there's no linear relation between usefulness.
Well, you could have two very far ideas that are close, but they're not useful, right? So, an interesting question. I know if you've looked much.
For usefulness, it's always an issue.
Great. Are there any other questions from the participants? Otherwise, I'm going to move to the next paper, and then we'll open this up again a little further. Okay, thank you, G. Our next paper is Nasser, Investigating Interrelated Reliability, paper on qualitative text annotations in machine learning data sets. I will open up for questions, but I will start with one or two for you. And these are probably a little bit more abstract, but I'm kind of interested in that you really looked in some ways at, say, Amazon or some sort of reviewer descriptions of these products, I'm assuming. Maybe that's not where they came from. And then you needed to use crowdsourcing to be able to annotate them. I guess I'm curious if this is an interesting mechanism. Well, one, is there a way to automate the annotation? I'm just curious. But secondly, is this a way to start to mine? You look at a lot of these reviews and they're all fake. A lot of them are fake. Or which ones are sincere? Is there a way to use this method to start to uncover that? I think you're muted.
So you touched on a few great points. I'll start with the fake reviews problem. It's definitely a huge problem for Amazon. There are tools that estimate how reliable reviews are for a product. So we kind of relied on that to select products that have a good amount of reviews and a decent, a high proportion of reliable reviews. We also only used, we filtered out reviews that have less than 20 words. A lot of fake reviews are usually short sentences that can apply for like any product, like, this was a great product, which you can just copy paste on any platform. So we try to take measures to minimize the amount of fake reviews that we analyze. And a key part of the motivation behind this method is to understand how customers perceive product features, because we found that a lot of times these perceptions can be different from how designers intend their products to be, or they're different from an engineering perspective. And so we're trying to fill this gap by better understanding the perception from the customer side, so that designers can take these into account. And so that's where these manual annotations come in, to basically extract these perceptions from the reviews.
Great. And we have a question for you from Oscar. I guess I'll assume you want me to go ahead again, unless you want to jump in there.
Sure.
Can you comment on whether the raters were?
Okay. Yeah. So the question is, can you comment on whether the raters?
Oscar? Oh, sorry. Okay. Yeah. So can you comment on whether the raters were trained for the rating task, and if so, how? Sorry. So why don't you go ahead, Nessa?
So the way that the experiment was designed was it was in a survey, and they went through a training process where we showed them how to perform the annotations, as well as giving them a brief guideline on what sustainability is. And then we also had them go through a basic test to make sure that they paid attention to this training process. And then based on if they passed, then they entered the annotation process, where these reviews were randomly pulled from a server, and then they were able to annotate the reviews based on the training.
Great, thank you. Okay, I'll ask you one more question, and then we'll move on to our last paper, unless somebody else speak up, please, if you have a question. I'm curious how this applies to, there's a lot of people obviously are mining conversations in design research. I'm curious how your results transfer into that arena.
Yeah, so I think if we take a look at how the traditional way of understanding customer needs is going through like surveys or focus groups, which can be difficult to scale, and there's also a lot of potential for biases based on how you phrase your question. Whereas if we're mining information directly from the reviews, these are like unsolicited information, like the customers voluntarily shared this information, and there's also just a huge scale available online from them. So I think there's a lot of potential here for designers to tap into that resource, and there's a number of like a growing research area that's going into this and coming up with design methods for mining this information. So the specific contribution that I'm making into this space, or trying to make in this space, is being able to understand these subjective topics, for example, like sustainability, where there can be a lot of like interpersonal factors that play into how customers perceive this subject, and how designers can better understand these subjective concepts and be able to factor them in, so that when they create a sustainable product, it's not only engineered to be sustainable, but the customers are also aware and understand the sustainability of the product.
Great, thank you. And then I'm going to turn to our last paper now, which is Niccolo, exploring the applicability of semantic metrics for the analysis of design protocol data in collaborative design sessions. And again, I'll invite people to ask questions, but I will start with one. I guess you already can somewhat anticipate it. But when I look in your paper, and I don't know that you had it in your presentation, but figure 3 of your paper really shows these different attributes and over time. And I'm wondering, about for these four different attributes of, again, polysemy, abstraction, similarity, information content. Did you expect some alignment? Some of these were aligned, especially I realized you had the no ICT protocol, but there were 2 with different protocols. Some of them were aligned and some of them weren't, and especially at different times in this process. And what does it mean that they're not aligned at the times that they weren't?
Let's say that this is a very first trial, since as Georgi stressed, we didn't use anything which is extremely tailored for this kind of application. So the WordNet thesaurus was considered in its entirety, not just, we didn't use a specific subset which could be capable probably of providing us with some more precise results than the ones that we had. So as this trial was just a proof of concept to check if and how much we can try to consider the application of this kind of techniques to somehow simplify protocol analysis, not just to completely substitute it from scratch. The idea is that the 4 metrics can provide us different angles of what is happening during the session. I see that much more than what happened with our data. Probably some things can be noticed in terms of convergence among the metrics on Georgi's data. As typically the information content follow something which reminds me the exploration at first, and then some kind of convergence to specific solutions, since the amount of information appeared to decrease after a certain amount of time after an initial raise. So the combination of the 4 metrics together actually enabled us in the 4th paper to check if the concurrent raise of different metrics would help us to spot something that within the protocols have been already evaluated as a critical moment for the design session. And actually, this worked kind of well. Actually, we have some false positive, but in the end, all the critical moments were spotted by means of the combination of multiple metrics, independently from what they mean. We also see some regularities, since one of the metrics typically do not raise as well as the others did. So apparently for some metrics, we have some, opposite behavior. But I think it's just a matter of having or starting applying this kind of metrics on a more reliable and probably larger data set, so that we can try to observe some regularities in the long perspective. So far, it's not easy to say something, but maybe with additional data, additional trials, we can try to define a nice methodology to extract even more meaningful information from this approach.
And then your one figure was pretty much looking at a sort of a macro level of different phases. And then you have very much more micro timestamps. And I'm curious, again, I guess it's the same question that I asked Georgi. But what's the resolution? How fine-tuned can you get to recognizing certain events?
Well, this time we were mostly driven, I'd say, from at least for what concerns the comparison with the segments in the protocol, we were driven by the segments. And actually, I can think that Georgi himself can confirm that the analysis was carried out really segment by segment. So in a way, to run this analysis, we had to start from something which was pre-segmented. I don't know, we need to ask Georgi if and how much it is possible just to consider nouns one by one instead of as sets, subsets contained within a segment, and if and how much this can provide different results.
Yes. Thank you. And actually, we initially thought that as absolute minimal fidelity of the method is like 5 nouns. So moving window of 5 nouns would be the most precise chunk of data that can be analyzed. We still have to get more data analyzed in that sense, but in reality, this is this kind of moving window of 5 nouns is resulting in maybe too frequent changes in the values. I would say bigger chunk of data will exhibit differences better. For example, I'm not sure how many words this corresponds to, but in the case of Niccolo's study, these quintiles probably correspond to something in the vicinity of hundreds of nouns.
Great. Thank you. So again, if there's any questions from the audience, I'll give an award out to more questions, although Oscar's asked 2, I think, so it's the award so far. Please do put them into chat. I'm going to ask a more general, yes, we'll buy you a drink next time I see you, if we ever see each other in person. But I do want to ask the panel a question as a whole. And I guess it's really, I have 2 questions, but given time, I'm going to ask this as one. When you think about the work that you've done, as well as others in the community are doing, how much of this is applicable today, and or what will it take for us to really be able to apply this work in practice to really have an impact on the design process from each of your, in terms of really semantic research? Does anybody want to take that question on? Sure, Niccolo, you look like you were ready to talk.
If you want, I can start. Sure. I mean, as I said, maybe we are not that close to really support design in the short term. We need to probably tailor the dictionary to something which is design specific, where we maybe include the meanings which are not that obvious. I think that maybe just focusing on nouns could be one of the main limitations, especially if one wants to dig a little bit more on the content, relying in the protocol itself. So maybe we can think about extending the specific terms, so nouns, but also verbs, just to check with a more precise scope what is going on during a session. I'm afraid that we are definitely a little far yet from having something which is really exploitable beyond laboratory studies.
Okay, great. Who's next? I'm going to ask each of you to comment. So
maybe I'll go next. Okay, so for my work is about semantic distance or conceptual distance, so I say. So the work why we do this research is to probably support computational tools and use computational tools to support designers. I think the real problem is not really about, for us, for our research, it's not really about semantic distance or conceptual distance. It's probably about the computational tool to use them in practice. So I've read a lot of paper and I have worked with a lot of designers. So basically, designers nowadays, they don't really use any of those tools. They don't use computational tools. And most of them, they don't really use any like creativity tools. They don't use like 6hat, they don't use Tris. What they do is they just brainstorm. They just generate ideas by themselves. I think that is probably especially for my research for computational creativity or for computational design support tools. That might be a real challenge if we want to use this kind of tools in practice. Yeah. Thank you.
Thank you. Nasser, why don't we go?
Yeah, sure. Looking at semantics and online reviews, I would say like this is something that designers can use today. Like, you know, marketing research, I think, was the first sort of space to look into this maybe 10 to 15 years ago, and then we started getting into the you know, semantic approaches to kind of automate these analyzing this content at such a large scale. So I think like designers can directly benefit from this right now. And in my specific case, the semantic approaches that I used are pretty basic, and that's intentionally so that we can make sense of what the models are doing, so that designers can utilize that information. So, you know, once you go into like deep learning, you sort of lose the interpretability. You get the result, but you don't know how it got there. And so we've, you know, and subsequent studies, we were able to see that that customers do resonate with these perceptions that we're extracting from a sustainability perspective, and we're looking now into whether these perceptions can actually influence a purchasing decision. And so that could be a direct benefit for a designer when they're creating a product, to make sure that it, you know, it reaches their target customer, and they're actually able to influence that purchasing decision.
Great, thanks. And Georgie, why don't you bring us home here?
Yes,
Closure.
thank you. Actually, this is very, very important question, and at least on in non-computational stage or on computational aspect of the issue, there are not so many problems. Actually, we already have developed real-time system to do this, that can compute these semantic parameters with delay of matter of 3 to 5 seconds from a real conversation. The point is how to make sense of this data, this kind of data, how this can be interpreted or fed back to the designer, and that's the biggest issue here, because it should be as much as possible, let's say, not interrupting the naturally occurring processes in such kind of conversation. And yeah, this is the biggest challenge we don't know yet how to address, to make something sensible in terms of feedback and interpretable in terms of feedback.
Great. Thank you. And I want to, perfect timing, we're going to bring closure to this panel. First of all, I want to thank our panelists and the papers. They're really interesting. I enjoyed reading them. I want to thank Ivan for his help as moderator of the session. And I want to invite all of you to go over to the closing stage right now for the closure of Design 2020. So thank you again.
Thank you.
Bye.
Bye-bye.